The question we'll be looking at today is 2 cosine squared of theta is equal to 3 sine of theta. And we'll be looking at values from 0 to 2 pi. Because we have both cosine and sine, which are two different things, we need to find a way to make them look the same. And we'll be doing this by looking at the identity of sine squared of theta minus cosine squared of theta is equal to 1. By moving things around, we get cosine squared of theta is equal to 1 minus sine of theta, and we're able to substitute this back into the equation. At this point, we need to use the distributive property to multiply in the 2 and move the 3 sine theta on the other side in order to make it look, in order to get all like terms on one side. At this point, we need to rearrange the equation to make it look like a quadratic. Because it does look like a quite hard quadratic, and the reason why is because of the sign, we need to substitute out the sign for u and write u into the equation. At this point, we need to factor the equation in order to get solutions, and we need to find two numbers that when multiplied together will give you 2 times negative 2, which is negative 4, and we'll add up to be negative 3. And those two numbers are negative 4 and 1. So at this point, we need to substitute back in the negative 4 and 1 for the b value. We need to divide the equation into 2 buckets and then factor out like terms in order to then get negative 2u for the first one, and then in the brackets we'll get u plus 2. And for the other one, we can only factor out 1, getting again u plus 2. Meaning that the 2 brackets will be negative 2u plus 1 times u plus 2 is equal to 0. At this point, we need to make each bracket equal to 0. So we have negative 2u plus 1 is equal to 0, and u plus 2 is equal to 0. So in order to find the solution to this one, we need to bring the 1 on the other side, and then divide by negative 2. Therefore, u is equal to 1/2. And on this side, we just need to simply bring the 2 to the other side. At this point, we need to factor back in the sine of theta. And now we need to treat each equation singularly. So for the first one, in order to find equations, we need to identify whether they're going to be, in which quadrant we're going to find them. So because we know that all students take calculus, we can figure out that the first solution will be found in the first quadrant, and the second will be found in the second quadrant. In order to find the degree of this angle and this angle, we need to use our special triangles. The first one is the 45, 45, 90 triangle, which can also be written as the 1, 1 square root of 2. And the second one is the 30, 60, 90 triangle, which can also be rewritten as the square root of 3, 1, and 2. So we need to find, because we know that sine of theta is equal to opposite over hypotenuse, we need to find an angle that has as its opposite a 1, and as its hypotenuse a 2. And that angle is the 30-degree angle. So we know that this angle will be 30, or pi over 6. So in order to find this triangle, we need to find how many 30-degree angles, or pi over 6 angles, there are in this quadrant. And that's 3. 1, 2, 3. And then there'll be 2 in this one. Therefore, this angle is going to be equal to 5 pi over 6. For this one, we know that sine of theta is going to be equal to 0. And that's because when looking at the graph of sine, we know that the maximum value is 1 and that the minimum value is negative 1. Therefore, negative 2 is not in the graph, making it equal to 0. This leads us to the conclusion that the only two solutions that we can have are 5 pi 6 and pi over 6.